So we're now up for our final presentation, and absolutely delighted to have AngelicvM Chile here with us. As many of you know, they were unable to make the summit last year, and so they have absolutely made up for it this year. And we're just delighted to have everyone here to tell us about what you're up to. You'll probably need this one, or you.
Thank you, Alex. Hi everyone, my name is Gerardo Rocha. I was a former airline pilot, flying the A340-600, and I was the president of the university after that in Chile, and now I'm chairman of AngelicvM Investments. Klaus Kunstort, he is the only and first Chilean candidate astronaut, almost made it to the space shuttle at some point, former jet fighter pilot of the Air Force, and aerospace engineer from the USC, University of Southern California. Mauricio Enriquez is in charge of robotics, development of the robot, and he is from the University of Southern Chile. And also we have a few members, I think we are the smallest delegation here, you can see it on the back. We have Darío Rodriguez, aerospace engineering from Universidad de Concepción. Can you raise your hand? Okay, Darío Rodriguez. Then we have Héctor Gutiérrez. He is satellite engineering and also from National Information Center, Satellite Information Center in Chile. Carlos Pino, also aerospace engineering. And where is Daniel Ojeda? Video and photographs of the team. And we have Alex, or Axel. Where is Axel? Okay, he's... Oh, Axel here is from the national newspaper from Chile. And we have Jorge Vidal, who is general project supervisor. So we came a few hours today just to counteract. We didn't make it to the last summit, I guess. And we are very delighted to be here with you. So the first thing I would like to say, and I think I make a point, many of you, we will thank very much the X Prize Foundation and all the effort they are doing. We will thank very much Google as well for having this competition. We appreciate that. And AngelicvM Investments is the only and first private company of Chile investing in aerospace development. We've also invited many other institutions, the next please, and University of Santiago, Chile, University of Santísima Trinidad Concepción, University of Concepción, the second largest city, and the only university that has aerospace engineering in South America. The National Aerospace Information Center, and of course the Southern Chile University developing the robot. Please, the next one. Also, an associated institution of AngelicvM is the AngelicvM Foundation, and is an associate member of the ICUSTA, International Council of Universities of St. Thomas Aquinas, which is all over around the world, and we are hoping, as we are working more on our partnerships, to make an effort on the education and outreach program that we may develop with them. And the next part of the presentation is going to be presented by Klaus.
Hi. I also want to thank you, Prize Foundation and Google, to give us the chance. It's an excellent choice for us in Chile to try to motivate the young people and try to hit to the scientific area. We export a lot of copper and fruits, but in the scientific area we are not that strong, but we have very good people who have very good capacities. But Chile is, most of you know, I think, where we are. but we are a very long country. We are about 3,000 miles long. We were probably the last team who started to work in this Express project. We finished our first process in December 2010, but we didn't have any team. We were just both of us. So on March or February of 2011, we started to visit different universities. Now we have 4 universities, and a 5th one is starting to join us also. We have teams all over the country right now, from Antofagasta up to Puerto Montt. We have here's our robot right now, and we are working here. This is our headquarters in Santiago, and we have a university here and another one over here. About our strategy, our goal is of course to send our robot to the moon and accomplish whatever it's needed to win this competition. But we really will not stop if we don't win the competition. We want to go ahead and send this robot whenever to the moon. And what's our purpose? I had an experience when we sent a little experiment with the high school in the year 98 to space with the STS-93. It was very exciting, and the mind of these young ladies changed a lot, and now they're more involved in science. So we think this opportunity of working with the Express project will give us something much bigger than what we experimented in that year. So this will hit also in our Chilean space industry. So we are planning to have some interaction in Chile with space. So in the areas where we're working right now is basically in the robotic rover, in the rocketry, and the communications. In the rover, we started from a basically very new concept we never seen anywhere. We hope it works. Up to now, it's working fantastic. Mauricio is the leader of that team, and he will talk more about that. We hope it should be ready in the beginning 2013. About the rocket, we know that we are not going to be able to send it from Earth to the moon, but we are dreaming and do it from a parking orbit up to the moon. We don't know, but that's the reason we are also searching for the choice to pay for a ticket so we can share a spot with somebody else. About communications, we're working on the communication, the data transfer from Earth to the rover to the lander. Mauricio will give you more information about the technical area.
Okay, thanks. As Klaus mentioned, one of our purpose for the team was that we know from the beginning that it was very difficult for a Chilean team to get to the moon, at least on the Google X Prize, that one. So we want to bring some innovation, at least in that period. So we try to think in a new rover concept. We have a very quick prototype methodology. We start with some brain ideas, then studies, build and test. And in 1 year, we do this already 3 times. We are in stage 3. Of course, we start looking at what you guys are doing, also what NASA do before, and also some other concepts that are developed by other universities to see what is the state of the art, what can we borrow, or what can be improved. And so also some ideas from us, original idea from us. bio-inspired concept rover design will meet the needs of the moon surface, dust, fine dust, and rocks. So we end up with a very reduced and minimalistic design. It's reversible, bio-inspired, and can be scaled from a little toy that we are going to turn a little more, from a cube size, and also a full-size rover that can be used for experimentation and other tasks. So we end up with a multi-purpose platform. The first one at the left is the micro dandelion, which is used for marketing purposes, educational purposes, and it's a toy. It's about $5 toy. The mini dandelion is a CubeSat size. Also, there is the full-size dandelion, which can be, it have more CPU power, so it can be a little more small. And also, a very last concept was the heavy-duty one. It's a reinforced dandelion that can be used in even more road terrain. Of course, every time you have what you see is an original idea, is not so that. So NASA have a concept kind of similar of what we have. It's called Axel. There was a previous lunar rover from Grumman Aerospace also for the all missions. The Recon Scout, and also even toys that follow kind of our principles, or we are follow those principles. So also we are studying, we already have some path planning, obstacle detection in 3D, simulation of the rover behavior, and all insect studies, because some of our principles are based on how the bugs and insects walks. Next, please. Also, we have the chances to test all these rover traction concept in the Moon Mars Atacama Research Station, which is at the north of Chile, at the desert of Atacama. Those are typical surface of the moon, and we can find very close surface on Chile, so it's a luck for us. We also are studying different approaches to reduce the size of the spur of blade or our rover, because the design is very efficient, but the spur of blade are very big. So for transportation, maybe it's a problem. So we are studying different approaches to reduce the size by collapsing the blades of the spur during the trip. As I mentioned, we are on stage 3. We can see the micro dandelion. Carlos is going to show us one of them. It's a toy that we build with kids, small children in schools. It's about $5 and they can build it by their own hands. It's a little piece of wire, a little solar panel, and some pieces of plastic. So they make a lot of fun building those kind of toys, and they can play with it where there is sun and there is an amount of sun that can make it bright. It's functional, but of course that light is not enough for him. Yeah, thank you. Currently, as I mentioned, the robotic guy are at the north, testing our rover in the MMR's facilities. So we are very happy with the result of the rover, and we succeed in all 7 experiments that we were doing on that. Yeah, there is some technical data there. We are happy to make the presentation public, but we don't want to succeed, like Mike says, so let's keep it on the funny or more interesting slide. About rocketry, as Klaus mentioned, we have 2 approaches. One, to start the rocketry development in Chile. That is a need for Chile, for South America, and so on. But also we want to look for financial approaches to pay a ticket to the low orbit of the moon, or land with some other teams on the moon, like guys at the University of Concepcion start working on DLI engines, brake engines, and they already have some prototype of those motors. There are some specifications of the motor that the guys at the Concepcion University are building. That's my part. I know that Gerardo wants to close the presentation.
Thank you, Mauricio. Then we are going to keep forward catching up with a lot of challenges we still have. I think most of us do have this kind of same challenges. Of course, one main challenge is to be profitable in the near, medium future. So even if there are non-profit organizations or situations, there's always be a need for funds. So we take this as a big challenge, and in a business way of looking at it, we will keep pursuing the way so this captures the attention of enough people, organizations, so to really enter the next private market age. The next one, please. And we have been able to stay in competition, and we have been in the National Aerospace Fair, which took place last March. It's the largest airspace fair in South America, and from that on we've been able to develop more partnerships. This is all evolving, so we expect a lot to tell you about in the next summit. And of course, we are thinking this is very important for us to reach the moon with a robot. And we know that we may do it inside the competition or outside of the frame of it. And as Klaus said, we are committed to this goal, and we expect to develop all the technology required to accomplish. And one thing I would like to share, when we win the GLXP, but otherwise if you make it first than us, we would like to share an idea that is to, because a lot of people is going to be watching you, is going to be watching us. I think it's a great opportunity to send the message of peace and union around the world, around the nations. We are coming from many countries and we're all working in this competition, so this is an idea just to throw in. And we would like to show you some videos and photos. Next.
That was yesterday on the Mars facility at the Atacama Desert. It's a reversible design, so it can be run from anywhere. Doesn't matter if it's in water.
Do we have any questions?
That's very cool, by the way. I was curious of what your assumptions were, like on your wheel loading, area per square inch sort of loads on that wheel configuration. Because it looks like that it would be something with a dust environment. It certainly looks like it would be I'm just curious if you have what assumptions you might have used on something like that. I know this is a very technical question, but I had to go to the old rover guys and ask them, what the pounds per square foot they used on those old rovers, and we sort of baselined some of their assumptions. Not that they were correct; they were very conservative, obviously, but we had to use those sort of numbers on your feet, on your landers, guys, as we design our things, even though they were overkill. I'm just curious on that wheel configuration. It's very different. I'm just curious how do you do something like that for this environment?
You have thought about how the traction system works and
It's just a matter of, I'm not saying it won't be, I think it'll have plenty of traction. It's just a matter of the loading versus digging in versus, floating on the surface, sort of a trade-off there. I think the traction would be very good, by the way. I don't doubt that. It's just, but I guess I'm just saying that. I just don't know. All the missions in the past were based on very conservative estimates for densities of surface. Now we have regolith and samples of that. I was just curious of how you might have went about that.
well, I don't have the actual data on that here, but the 7 experiments that are currently running on the Mars show us that in all kind of topological surface that are commonly found on the moon, and we have the similar ones on the Atacama Desert. In all those surfaces, the traction works pretty well. But also we want a design that feels comfortable in those surfaces. That's why our rover can be reversible, so it doesn't have a top and bottom. It can be driving both ways. So we can change it, we can make it turn or try to rid off if we get some indeed of the fine dust. I don't know if I answered your question.
Well, almost. I think it'll have great traction, but if it's super fine dust, I can see it sort of wanting to dig in a little too much, maybe. That was my only sort of.
It was a worry on us too, but the tests show us that it behaves pretty well on that kind of surface. But even saying that, it's probably that the final version is going to have a little more blade on the wheels, not like rounded like it is right now. But even with the current one, it performs very well. Very good, thank you.
No one wants to hear me entertain a chip. I'm curious, the design of your wheels is fantastic. Are you planning on using shape memory alloys to make that actuation from the stow to the deploy position? What sort of device do you plan to baseline to that? That looks really fantastic.
You're asking about what material we want to use for the spurs or for the blades? Okay, for the prototype we are using different kinds of metal, very common metal, with some knowledge about which one would be better for space for the moon surface temperature. But now that we are working with EXA, they have very smart material, new components, and some of them intelligent components or materials. So we are working to have a closed version that can travel inside a CubeSat size, and that kind of material on the moon surface, it can expand and take the final spur configuration.
Thank you.
Anybody else have any further questions?
I'll go.
I have to say, we happen to have, courtesy of these wonderful gentlemen, one of the little toy dandelions lives on Amanda's desk.
Question?
We got something you
Don't
have.
When can I buy the toy?
Okay, we have one for you.
I knew you were going to ask about the toy. It is.
Well, to be a surprise, but just
There you go. It is truly an object of desire. See, everyone's going to come in.
have a little fish, but we have a little fish. So
This doesn't. Oh, where's the switch? This doesn't suck. Wait till you turn it on.
if we can find a lantern, maybe we can make it run.
Or we go outside maybe, yeah.
But where is it? If it's too low, it's not going to run.
Yeah.
You're going to have so much fun making that climb over anything you can build in your office. It's a lot of fun.
It's about $5. We are going to make more massively amount of them this year, and even if the price is going to slow down.
Fantastic. Any further questions for Team Angelica?
One second.
Thank you very much indeed, gentlemen. Another inspiring presentation. So there are a couple of administrative